Replacing castings with metal 3D printed parts is a big opportunity, but it also brings some challenges. This is an example. This is a bracket for the Department of Defense. Specifically, it is for the Marine Corps, and it's basically a giant trailer hitch. This is something that would be cast and then machined, but you can see that it's a little bit difficult to do that because of the way that it's leaning. That's intentional. This is the way the part is supposed to look. This part was made by Formalloy. I'm at the company's facility in San Diego, California, where they are building and using printers made for directed energy deposition. The company offers modules for both powder-based and wire-based DED. This particular part is Inconel, and it was made using their powder-based technology. They were able to produce this part within just a couple of days, saving lots of time that it might have taken to have it cast and then machined. So Formalloy is finding lots of applications, lots of opportunities for parts like this, but it also comes with a few challenges. When you're replacing a casting, customers have a lot of questions about whether the 3D printed part is going to have porosity, whether there's microcracking, how they should inspect it, how they should think about these parts. And so Formalloy's answer is coming in the form of lots of sensors and lots of data generated throughout the build. So they are capturing information about every single point on each of their builds. All of that data is getting stored, and then the customer gets a report at the end of every build, a PDF that has graphs and interesting data points that they might want to investigate further. The point is not to replace CT scanning or other types of secondary inspection, but to alert the user when there is an anomaly, where there is something that they might want to look further into and try to figure out what the cause was and whether it's something they need to be concerned about or not. And the sensors are not just capturing information about what's happening at the part level, they're also looking at different things that are going on inside of the machine. Things that might affect the way that your part comes out or the way that your machine is performing. Even something like dirty optical glass can take energy away from the laser, which means that energy isn't going into the melt pool, and that can cause defects. And so they've tried to add sensors to the machine that basically replicates anything that a human operator standing by would see as an issue and want to stop the machine, try to correct it, try to figure out what's going wrong. The interesting thing here is that 3D printing as a replacement for casting also gets you a lot more information than you would ever have about how your casting was made. Because the part is being built layer by layer in the DED process, and because Formalloy is able to capture data about every single point, there's a lot more information about how this part was built. They actually know what is going on in each individual layer, they know what's happening inside the printer, and they can report all of that back to the user. And so 3D printing as a replacement for casting brings all these great benefits with geometric complexity and with speed, but it also offers the opportunity for us to know more about the parts that we're making and using.